Hello and welcome to Chapter 16 Energy, Video 5. By the end of this Video 5, you will be able to describe some possible transformations of kinetic energy. Okay, recall that kinetic energy is the kinetic energy, or rather the energy due to motion, and it can be calculated by half mv squared. We also saw that the various forms of potential energy can be converted to other forms of energy. Okay, for example, consider a falling ball at rest. Okay, it will have gravitational potential energy. And when you release the ball, okay, the gravitational potential energy is converted to kinetic energy fully when it hits the ground. Okay, so that is one example of gravitational potential energy being converted to kinetic energy of a falling ball. Okay, so now let's look at the demonstration. Okay, I have a steel ball here and a wooden ball here. Okay, so you can see that they have different sizes. Okay, steel ball is smaller and wooden ball is larger. But you know from your class that the steel ball is heavier than the wooden ball. Okay, so what we are going to do is to release the two balls at the same height, okay, onto the foam below here. Okay, so what's going to happen is that when you do that, the balls will hit the foam, okay, and when you remove the ball, you'll see that they make some holes, okay? So the impression or the hole that is made by the wooden ball is this one, and the steel ball is made makes a deeper hole. Okay, so here we say that the foam has changed shape. There are now holes caused by the balls, okay? And we use the word deformed to describe this situation. Okay, so this is what kinetic energy can do, which is to change the shape of a material or to deform a material. Okay, so now why is it that a hole made by the steel ball is deeper than the hole made by the wooden ball? Okay, so let us explain. Okay, so we have established in chapter 5 that both balls will reach the ground at the same time, so they have the same velocity. Okay, now which ball has the larger gravitational potential energy? Now it is the steel ball. Now remember that the two balls are released from the same height. Okay, so they have the same height. Okay, and here's the formula for gravitational potential energy. So if they have the same height, h is the same for both balls. But since the steel ball has a larger mass, okay, so that will mean that the steel ball has a larger gravitational potential energy. Okay, so once you release the balls, okay, and the balls hit the foam, which ball would have the largest kinetic energy? That would be the steel ball as well, because it had more gravitational potential energy to start with. So when converted to Ke, it will have more kinetic energy. Okay, so now since the steel ball has more kinetic energy, it has more energy to give the foam. And what does the foam use to do? What does the foam do with the extra kinetic or the more kinetic energy that the steel ball has given it? Okay, and now of course that the foam uses that energy to make a hole. Okay, so here's the story. The steel ball, when it hits the foam, it gives its kinetic energy to the foam. Okay, and the foam uses that extra kinetic energy, okay, to make the hole. Okay, so since the steel ball has more kinetic energy upon hitting the foam than the wooden ball, hence the hole that the steel ball makes is deeper. Okay, so so we have seen that the kinetic energy of the steel ball is used to actually make a hole in the foam, and that's what kinetic energy can do. Okay, to make holes, to destroy or deform your objects. And one application of this kinetic energy using kinetic energy to deform or destroy your objects is in the demolition of buildings. Okay, so a heavy steel ball is used because you know a heavy steel ball, okay, has more. The heavier the ball, the more GPE it has, and then it can be converted to more kinetic energy. Okay, when it then hits this building, in this more kinetic energy of the heavy steel ball is then used to deform the brick or concrete, thus breaking the brick or concrete apart. Yeah. Okay, so the kinetic energy in this case is used to actually break the concrete and break it apart so that you can demolish the building. Okay, And also it can also be kinetic energy can also be used to convert to electrical energy, and in this case the device that you need is a wind turbine. Okay, so you need a wind turbine to convert the motion of air to electrical energy, and you need not go very far to see a wind turbine. All you have to do is to go to T12. Okay, look at the rooftop of T12, and then you will see a wind turbine there. Okay, and that's how we can convert kinetic energy to electrical energy. Okay, so we have come to the end of video 5. Okay, let's summarize. We can see that kinetic energy can be converted to other forms of energy. For example, using a wind turbine, we can use kinetic energy to convert it to electrical energy. Okay, we can also see that we can use kinetic energy to actually change the shape of a material. Okay, so and we have come to the end of video 5.